PTB Course Unit 3 Walkthrough. In this walkthrough, we will demonstrate project scheduling with the PTB. We begin by opening the scenario elearning/walkthroughs/unit3 deterministic.scn. Notice that at this stage, the project or problem space has already been defined with the scenario builder. Our goal is to create a good plan for the project and to follow through the execution of the plan until the project is successfully completed. We will concentrate on the time management aspects. The first piece of required information is what would be considered a timely completion of the project. In order to see this information, click on the Scenario Info button. The target date for the project is time period 22. If we are late, that is, the project is finished after more than 22 time periods, we will pay a penalty of 50 for each period we are late. On the other hand, if we are early and the project is finished before 22 time periods, we will receive a bonus of 100 for every period we are early. In addition to the due date, information on the project scope or work content is required for project time management. By clicking on the Tasks button, we can see this information as a list of tasks along with the precedence relations among the project tasks. The PTB assumes finish to start precedence relations. Thus, for example, the task software development can only start when its two predecessors, software design and hardware design, are finished. Another, perhaps more convenient way to view this information is the Activity on Node network diagram. By clicking on the Network button, we can access this view. In this network model, each node represents a task to be performed, and the arrows represent precedence relations among tasks. Here, we can also see that the task software development can start only when its two predecessors, software design and hardware design, are finished. The next piece of information required for planning the project is the duration of the tasks. At the planning mode, the duration is forecasted or estimated. To see the duration for a task, we click on it. Let's click on the task Hardware Design. We can see that the task has one mode of execution, main mode, and that the optimistic, most likely, and pessimistic duration are 5. This means that this task duration is deterministic. This is a simplistic approach, and usually in real projects, we cannot forecast the exact duration. In the next part, we will learn how to deal with stochastic task durations. Create a default plan by pressing the Plan Default button. Notice that this plan is an early start schedule. To view the plan on the Gantt chart, click the Gantt chart button. In the Gantt chart, each bar represents a project task, and the duration of the tasks is represented by the length of the corresponding bar. The horizontal axis represents the time since start of the project, and the leftmost point of each bar representing the task indicates its start time. The rightmost point of the bar indicates its finish time. In our case, the estimated finish time of the entire project is time period 22. For example, the task hardware development is scheduled to start at time period 5 and to finish at time period 13. The reason it is not scheduled to start earlier is that it can only start once the predecessor task hardware design has finished. We can compute the critical path by calculating the early start, early finish, and late finish times for each activity. Or we can use third-party software, such as Microsoft Project, if it is installed. To do this, click on the Export Scenario button. Once in Microsoft Project, you can view the critical path. Microsoft Project does not take into account information included in the PTB, such as different modes of execution for a task and stochastic variables. If we change the duration or start time of a task on the critical path, this will affect the entire project duration. Once we know the critical path, we can choose a late start schedule. Select non-critical activities and delay their start time by the slack. For example, delay the non-critical task software design to start in time period 2 instead of in time period 0. Do this by dragging the task in the Gantt chart. Another method for changing the start time is by editing the Start At field in the Task Information view. In real-life projects, it is very hard to precisely predict the duration of a task. In the PTB, we represent uncertainty in the duration of tasks by estimating the shortest possible or optimistic duration, the longest possible or pessimistic duration, and the most likely duration. This 3-point estimate is available for each alternative or mode to perform the task. The range of task duration is defined by the two extremes, the optimistic duration and the pessimistic duration. The most likely time tells us if the duration distribution is symmetrical or skewed. To see this, open the scenario elearning/walkthroughs/unit3stochastic.scn. Click on the task hardware design to see its details. This task has one mode of execution. The most likely duration is 5. The optimistic duration is 3, and the pessimistic one is 8. The stochastic duration has to be taken into account when planning and executing the project. Create a default plan for the project by pressing the Plan Default button. Now open the Gantt chart. The durations of the tasks on the Gantt chart are in accordance with the most likely durations. Let's start running the simulation. Unlike in the deterministic project, the duration of the tasks is not necessarily going to be the same as the most likely duration. Some tasks might take more time periods to execute and some less. Your concluding assignment is to simulate managing a simple radar development project. The exercise focuses on the scheduling aspects you learnt in this unit, scope aspects learnt in Unit 2, and the trade-off between project time and scope. Run the simulation from beginning to end twice. In the first time, try to achieve the maximum range of the radar system. In the second run, try to finish the project as early as possible. Notice the trade-off between the radar range, or project scope, and the scheduling aspects. To begin, open the file elearning/exercises/unit3.scn. Good luck!